Hi everybody, welcome to TIA Now. I'm Clarence Reynolds. As we expand and connect the network of the future, entry points for cyber attacks and other security vulnerabilities will demand a robust cyber and physical security response. Here to talk about that response is Carlos Solari, Vice President of Cybersecurity Services at Comodo, Travis Russell, Senior Director of Cybersecurity at Oracle, John Schiel, Principal Architect at CenturyLink, and Arnab Roy, researcher at Fujitsu Laboratories of America. Thank you all for joining us.
Thank you.
Carlos, I want to start with you. Just talking about the changing nature of cyber attacks, are they actually changing the way we think about and start to implement deployments of new network infrastructures?
They are changing. In 2017, all the news was about ransomware. Today, we're getting threat intelligence that's actually telling us that there's been a pretty major shift with regards to malware that is targeting cryptocurrencies. So there is that adjustment, and it stands to reason to some extent because you understand that it does follow the money. And so when you see where these attacks are actually occurring, they're actually correlating to where the use of cryptocurrency is occurring. So that's an example. There's another one that has to do, the one that is certainly very much related to the topic we're talking about, which is a lot of testing taking place in terms of attacking, how to attack critical infrastructures, industrial control systems. A lot of learning that is taking place, certainly the government is paying attention to that, and that's something that we need to be mindful of. This critical infrastructure we call telecom is moving into the 5G types of networks, and we have to figure out to make sure that it stays reliable, it stays available always, because we're going to put so much traffic on it.
On the crypto point though, there's actually two parts to that. There's the ransomware portion where they're putting something on there and trying to ransom your systems, but then there's also software they're putting on to do crypto mining.
Yes.
Clandestinely, and then also there is one company, I can't remember who it was, part of the AUP was, when you're down cycles, we're going to use your computer to do crypto mining. Do you agree if you use this service? And most people just click ahead and say, fine, use my machine when I'm not using it for your crypto mining.
That's right. In fact, that's exactly the kind of malware that we are talking about. Some of it is rather voluntary,
right?
And some of it is actually very, very hidden, so that it's using these networks, the dispersion that is part of blockchains. That's an important part of that. Yeah.
Right.
Some of this is actually very sophisticated. So around smart contracts. So smart contracts are blockchain elements that can execute, right? And they are linear pieces of code, but it's not always obvious what the objective of a smart contract execution can be. So the semantics actually depends on the distributed systems that is also participating in this larger algorithm called the consensus protocol, right? And depending on at what point your execution is, you can do like out of order execution of these elements. You can play with the timestamps. You can do many of these attacks that were not possible in a vanilla blockchain system.
Another major shift that we have seen in hacking attacks, if you go back to 1974, some 83%, according to I forget who the poll was from, was around trying to steal some kind of a tangible asset. Now it's more towards stealing information.
Right.
And when we look at some of the attacks, we think, well, that's really doesn't make any difference. I mean, so what? They got my IMSI, for example. That doesn't make any difference. But what's happening is they're stealing bits and pieces of information using multiple attacks, and then they bring all of that information together for a much larger attack.
Right.
So we're seeing a lot more of that happening in the networks. And it's very hard to gauge because it's not like this massive attack that comes in, you see all of this traffic. They might just target one person and pull a little bit of information and then disappear. So it becomes a lot more difficult to be able to detect that and track it.
So with what we're doing to the network, we're adding cryptocurrencies, which is probably going to take an uptick in usage. We're also adding in IoT, what some say is 1 billion devices. How do we implement security on a level that gives us the confidence to be able to use those things?
Yes, and by the way, the numbers are, for some, the number is 20 billion devices by 2020. Some have said 30, and others have said 50.
I've heard the trillion word as well.
Yeah, but I think that's a little bit further in the future. The point is, from the current 6 to 7 billion devices that are connected, it's going to dramatically grow. And IoT is going to be basically sensors embedded in everything, including, as we've talked about, humans. So all of that is going to take, and this is a part of the conversation that we were having earlier, it's going to take architecting the security first, before you throw the engineers at doing the security, but it certainly needs to be upfront, part of what is being done now, because as we look at the legacy systems, the systems that already exist, we know how vulnerable they are. It's been exposed many different ways, and every time we test these systems, it's pretty scary how vulnerable, in fact, our critical infrastructures are that run on these industrial IoT systems of the past.
And that's why, in 3GPP, when we looked at narrowband IoT devices and the impact that they could have on critical infrastructure, we actually introduced the service capabilities exposure function so that those devices connect to a specific function in the network. They don't take the same path as a phone or a user data session would. And that way you can better control and manage, not just when those devices wake up and send data, but you can actually use that function to control when those devices wake up and send.
That's an example. Data. That's the kind of architecting security that can be done in the network.
That's a good idea. So we use the same kind of idea when we're protecting our network, is when you have, especially a network time protocol, NTP server, those are used heavily in DDoS attacks. So they can, they're thousands of times amplification factor. What you do is you put in a control and you say, okay, you can't talk to the world, but you can talk to these 3 servers over here. So that server, that NTP server, is not going to respond to just anything. It says, I'm only listening to Carlos and Travis.
And where does that NTP actually signal come from in many cases nowadays? It comes from a little satellite up in space called GPS.
Then people, because of that vulnerability though, people have gotten away from NTP and now they're using GPS.
That's right. And Arnab, you've been talking about protocols and the importance of that and protecting the protocols and looking at it from a full stack perspective.
And with the foundation being really important.
Right, so the reason is that these protocols are being millions and billions of times, even in the matter of days. So, so my point was, I was talking about this with John, that it's a balancing act. Analyzing protocols for security is hard. It takes time.
Yeah.
But do we want to wait for a good thing to come out of it, or are we going to be impatient and roll things out which can break, often in devastating attacks. So sometimes it's a question of risk versus gratification.
Right.
But when you're looking at very critical, mission critical systems, then it is perhaps better to analyze them very, very thoroughly in a full stack way before deploying them.
Well, and smart speakers are a prime example. There's 2 major players that we know of that are doing smart speakers. If you wait too long though, the one that came out with smart speakers may have not been the one that came out with them.
Right.
So the second player that, to your point, if you take the time to vet the protocol, maybe the second smart speaker player did that and made it better, and now they're starting to overtake the market. So I see your point.
Yeah.
But it can slow things down.
Right.
Yeah.
How should we go about defining roles in cybersecurity? Who should do what when it comes to implementation?
There's a big argument about training and educating users, and I think that's the wrong place to start. I think we can, we need to recognize that the human's probably going to be the weakest part of this whole security design, and so we need to put a lot of the security in the service provider, whether it's a web host provider applying security there, whether it's the telecom carrier providing security wherever the instances of processing actually takes place. And we know what's happening there. Everything is going virtual. We're moving intelligence further down the network, certainly from the edge all the way into closer to the home. So at the endpoint, that's where a lot of the security actually needs to be taking place.
I don't think it's just strictly the network provider's responsibility though, because I think working hand in hand with the consumer and other entities, we can educate that consumer and make them own part of that security as well.
Yes, and we've disagreed a little bit about
Right.
that before.
So if you bring the device and you want to put it on my network, I need some way to say, no, you can't bring that here. But the only way I can do that is to penalize someone.
Yes.
And so my easiest thing to do is penalize the consumer. Now they're mad at me because I won't let them on the network.
We don't want to go back to Carter phone again.
Right, but they need to have some responsibility too. I mean,
Yes,
they're
every time,
responsible for driving. They're responsible for following all these other rules for society. I don't see why we can't implement some controls that they need to be responsible for as well.
Yeah, and I won't. I don't disagree with the importance of that. I'm saying there should be less dependency on the end user and more on the provider, and shift that balance a little bit more. And every time we come to that conversation, I think of my dad and the little pop-up things that say yes, no, and sometimes he chooses the wrong.
Well, and the companies that sell the stuff, the guys in the middle, I mean, they should have a little skin in this game
Absolutely.
as well.
Yes.
I mean, because they're the ones that are buying the cheap stuff that comes from Asia, and they sell it at
Right.
a discount in their big box stores. So they probably need to have a little skin in the game too.
Yeah, and we've talked about critical infrastructure components. They absolutely need to be
Right,
certified,
right.
tested, and validated that they're fit for the purpose of what they're going to play.
But
you
you have
know
to be careful though, because you have those counterfeit devices. I mean,
Yeah.
there's purses that have famous names on them that are sold on
Right.
websites. It's a counterfeit.
Well, sure, you can.
So we still have
You
counterfeit
still have the
IoTs
testing that
as
has
well.
to take place.
Right.
Yeah, and the other big challenge that we've had, is we in the standards bodies, anyways, is we're trying to define, to your point, who's responsible for what. How do you classify IoT? Is it critical infrastructure? Is it industrial? So there is work underway. Addis is working on defining some classifications for IoT. I think that some of that work is being done in the GSMA as well. I think that's critical because until we understand what kind of a device it is, it's really kind of hard to point to anybody. The other thing we got to be cognizant of when we start looking at the regulatory front, look what happened in Europe. I mean, not just GDPR, but NIS directive.
Yes.
NIS directive holds the network provider fiscally liable when there's a breach on their network. So now, here again, the operator gets most of the angst here when there's an attack, even though they're the victim here. So we kind of have to be careful that those types of things don't get implemented here.
Yeah, it probably merits a little bit of a conversation around GDPR, how the strong emphasis on privacy has really shackled the ability of law enforcement to do the job that it needs to do. And so I think we need to find a better balance than the one that exists right now.
I get a lot of conversations where people say everything should be encrypted end to end and the operators can't see anything. The problem there is when you got a misbehaving device, the operators can't see anything. So
Right.
it just continues to misbehave.
Well, plus the additional cost of calculating that hash key is going to slow things way down.
Oh,
So
sure.
where in that process do you look to make sure that things are breaking? You can't.
Yeah.
Okay, but there's been big push towards making websites migrate to TLS instead of just being
Web
HTTP.
2.0, right?
And
Everybody wants that.
most big sites have done it.
Yeah, that was my points that I harped on, that there needs to be websites before they're allowed to be on the internet need to have some level of protection there because there's so many of them. There's over 600 million active domains that exist, and that makes for a very powerful botnet if they're not protected.
So companies can do things. I think Google and the Mozilla organizations have done really well because they've come out and said, especially Google, after this point in time, we are not accepting TLS 1.1. So if you want to be able to use our browser, then you need to change your keys. And a lot of companies are responding. I mean, you see that in OWASP and Mozilla.org. They have recommendations for the different ciphers as well. So.
Well, it'll be interesting in 5G because HTTP 2.0 is the protocol for transport over TLS in 5G. That introduces some problems as well, back to your point. Now we're starting, if it's encrypted all the way through, where can we start looking for issues within the network? So it's going to be interesting how that plays out. But here we are in 5G introducing HTTP 2.0 with RESTful. and stuff that's been around for a decade at least.
Yeah.
So hackers are going to have a lot of knowledge and a lot of tools to play with that.
We are.
Yeah.
Well, I want to thank you guys for being with us today. Thank you for your insights. And of course, you can see more videos on our website at tianow.org and on our YouTube channel. Thanks for watching.